Hello everyone, in today's video we are going to look at the first 10 classes of alkenes. Alkenes are classes of saturated hydrocarbon consisting of only single bond between carbon atoms. The first 10 classes of alkenes which we have are the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Let's see how we can write this down. We said the first one we have the methane, we have the ethane, propane, butane, we have the pentane, we have the hexane, we have the heptane, we have the octane, we have nonane, and we have the decane. So these are the first 10 classes of alkene. So let's assume you need to use the name and it seems to be hard for you to cram it off it. We can simply use mnemonics in order for it to be easier for us to put this back. The simplest mnemonic which I'm going to provide for us here is my elephant prefer blue pineapple, however, hungry ostrich never do. So, let's try to use the mnemonic. We said my elephant prefer blue pineapple, however, hungry ostrich never do. Sorry, my spelling of never is incorrect, but let's just use it that way. If you look at the mnemonics, I think this is easier for us to cram. If you look at the mnemonics here, if you said my, this is simply going to be methane. What about the elephant? This is ethane. Prefer, and this is propane. Blue, this is butane. Pineapple, this is pentane. However, this is hexane. Hungry, this is heptane. Ostrich, this is going to be octane. Never, this is going to be nonane, and do, this is going to be decane. So in this case we have obtained our mnemonics, and I think that this method is easier for us to cram. So the general formula for alkenes which are saturated hydrocarbon is what? The general formula is CnH2n plus 2. In this case, our N here, it represents the number of carbon atoms in the alkene molecule. You can put it different. You can set CnH2n plus 2 indicate that each carbon atoms form 4 single bonds with other atoms, and there are 2 additional hydrogen atoms for each carbon atoms. Let's take an example with methane. Remember, this is our formula. Methane is the first one. This is simply going to be CH2. Remember, this 2 seems to be constant. Plus 2 is going to be plus 2 here, and at this point this is going to be plus 1, and this is going to be plus 2. And remember, this is going to be continuously. Let's take an example with methane. Cn, remember we said our N here is the numbers of what? Carbon atoms in the molecule, right? So if this is the first one, it's going to be C1, which is methane, but since it's 1, we don't need to write the 1. This is going to be C. 2 plus 2 is simply going to be 4. And this is the molecular formula for methane. What if we are moving to ethane? Remember, this is going to be +1 in the case of carbon, and in hydrogen we have constant 2. We will keep on adding 2. Therefore, in the case of ethane, this is going to be C. Initially there is 1 here. 1 + 1 is going to be 2. 4 + 2 is going to be 6. In the case of propane, we are going to +1 carbon here, +2 hydrogen, and this is how it continues. So we are going to take the first 10 classes of alkanes one by one. We'll explain some basic information about, starting from the molecular structure, chemical structure, and everything possible. Starting with the first one. First one on the list is methane. In this case, methane is a chemical compound with the chemical formula, as I mentioned, CH4. 1 carbon atom bonding to 4 hydrogen. And the structure of this, it has a tetrahedral shape. And this is a tetrahedral shape. It has a tetrahedral shape around the carbon atom because carbon normally is at the center, saturated with, since we said 4 hydrogen, this is going to be 1, 2, 3, 4. And remember, as we mentioned earlier, this formula is derived from the CnH2n + 2. And remember, methane is the first one. You can choose to do it this way. The structural formula, and nothing changes. This is also methane. In this case, the one with red simply indicates the hydrogen, while the one in blue at the center, this is simply the carbon. And everything here is still what? Methane. Let's try it the other way around. Let's put it differently. We can also set methane. It can also come in this form: 1 carbon saturated with 4 hydrogen, which is just the same thing as this, and is the same thing as the one which I just get rid of. Or you can choose to do it this way: 1 carbon saturated with 4 hydrogen. Next on the list, and this is the structural formula, next on the list we have the ethane. Ethane is a chemical compound with the chemical formula, let's say ethane first. It has the chemical formula of C2H6. This is simply 2 carbon atom bonded to 6 hydrogen. We say 2 carbon atom, carbon bonded to carbon, saturated with 6 hydrogen atoms. Or we can also do it this way, the structural formula. This is carbon bonded to carbon, saturated with 6 hydrogen. This is 3 and this is 3. This is also ether, and these are what? These are the structural formulas. So next on the list is propane. Next on the list we said is propane. Propane is a chemical compound that is made up of 3 carbon atoms and 8 hydrogen. We said 3 carbon atoms and 8 hydrogen. This is simply the structural formula: can be carbon bonded to carbon and another carbon bonded to carbon. At this point, the one at the middle is going to contain only 2 hydrogen, while the ones at the end is going to carry 3 hydrogen. 3 by 2 is 6. 6 plus 2 is 8. This is what? C3H8. You can choose to do it this way. Since we have 3 carbon, this is simply going to be, let's say 1, 2, 3. Saturated with how many hydrogen? We said 8. Remember, this is carrying 2 hydrogen. This is going to be this way, and this is carrying 3 hydrogen. This is 2, 4, 2, 4, 6. We are remaining with 2 hydrogen. And this is also a structural formula for propane. Next on the list is butane. We said butane is a combination of 2 hydrocarbons or alkenes, where it is further composed of carbon atoms which are linked in a straight chain. In this case, if you take a look at it, if our propane previously is C3H8, we said this is going to be what? +1 in the case of carbon, and this is going to be +2 in the case of hydrogen. Our butane here is going to be C4H10. So the structural formula for this is going to be carbon bonded to carbon, carbon bonded to carbon, and another carbon bonded to carbon. The ones at the middle are going to be 2 hydrogen each, while the rest, the 2 at the end, are going to be saturated with 3 hydrogen each. You can decide to put it differently. You can set, if this is 1, 2, 3, let's say 1 CH2, CH2, and CH3. Here is going to be CH3. This is also a butane, because if you notice here, if you calculate the numbers of hydrogen and the carbon, here we have 1 carbon saturated with 3 hydrogen. Here we have 1 carbon saturated with 2 hydrogen. Here we also have 1 carbon 2 hydrogen, which is here, and this is what? 1 carbon 3 hydrogen, 1 carbon 3 hydrogen. Therefore, this is the same thing. You can choose to draw the structural formula differently also. You can set, if this is 1 carbon, 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 and carbon. Remember, we have 4 carbons. This is C4H10, 1, 2, 3, 4. Next thing we need to do is to connect the numbers of hydrogen. And remember, the number of hydrogen in this case is 10. So, this is going to be 1, 2, 3, 4. This is going to be 3, 5, 6, 7. Is going to be 8, 9, and 10. And this is also butane. You can choose to do it this way, 1, 2, 3, and this is also butane. So, next thing on the list is pentane. But before that, let's discuss about chemical formula. Chemical formula of a compound is a symbolic representation of its chemical composition. And when we talk about chemical compound, let's say we have water. The chemical compound of this water is H2O.